correct on this. I'm
Yeah,
not sure.
it's 1.5.
I'm not sure what's by the other.
No, the additional factor.
Sure.
Okay, so
Yeah,
service
it's a
factor multiplied by power requirement. So we have a total design power of 15 kilowatts multiplied by 1.5.
Yes.
Which is 22.5 kilowatts is our design power. And if I understand that correctly, that's what we have to select our drive to be.
1.5.
Okay.
That's what we have to select our drive for.
Okay, multiply that. We've done step 2.
Excellent. Okay.
Determine belt pitch. Okay.
The pitch. Okay. So now, essentially, the pitch is selected by speed and power.
Okay. So RPM of faster shaft.
Okay. So it's 1,500 moves per minute.
Right. Somewhere here.
Our design power, we're talking about 22.5.
Yes. So we have a range of the 8M GT.
Okay.
Yeah.
Or this is pushing the limit to the
Yeah,
so
we're
it's
on
like
to the
boundary
5. I think we probably don't want that. We're a bit too close.
to the
See, say about
wood
there.
pit.
It's yeah, the
We can
5.
get away with.
The 5. We're checking them all. 5M GT
Mm-hmm.
or 8M GT are the types of belt that we
We might be able to.
system we can actually have.
Okay.
Is there any other alternatives? What's the next page?
Okay, there's HTD.
Okay.
Page
HTD
15.
22.5.
22.5 to
So,
1,500.
So we're on 8M for the HTD.
HTD 8M range.
Okay.
And this one here is classical timing belt.
I'm not sure. I'm not sure.
I think it's a bit.
Yeah, it looks to be on the border.
Yeah.
I think we were.
We can.
Right. Okay. Now we have to select the actual belts.
Pulley combination, belt length and center distance. Okay. Okay, what we have is the center distance.
It's 550.
550.
The top. This is between
This
the
is
motor
given, yeah,
and
the main shaft.
The leg. Okay.
Center to center. Okay. Standard and non-standard speeds. Calculate speed ratio.
Okay, we know. Oh, we
have to select that.
We've made a decision yet.
Should we just try 3.3?
We'll try 3.3.
We might have to we might have to iterate.
I mean,
Yes,
the benefits
yes.
of buying, I assume we buy the same system for
Same
both.
sets, yeah.
Should be easier.
Okay. So we have that. We have the speed ratio. In the center distance tables, refer to the column headed speed ratio. Locate speed ratio nearest to your requirements. So the page is for 8M and 8M and GT.
Were they viable drives? Yeah.
Yes.
We could have them. So speed ratio we want.
So this is page 70 in the catalogue.
Yeah.
So if you have 3.3.
3.3.
Okay.
We have drive R group of 24.
Okay, so we need
Yeah.
some to read straight from
Drive R group 24 and drive N 80.
here. Okay, we won't actually reach this page. The centre distances aren't long enough. Is there a separate
Center
page?
distance.
No, that's the length of the belt. The actual
Okay.
reading centre distance. So we got the page which is we won't. It's reflected the other way across. So on page 71 we can do a similar thing. So we have centre distance is 507 or 587.
7, whichever.
We do have a tolerance on this, by the way.
Yes, we will give it the tolerance.
Note the above dimensions have a tolerance minimum of plus or minus 20 millimetres. That's in terms of the axial direction of bearing and pulley.
Yes.
Now between the motor, pump and shaft of plus or minus 50 millimetres.
So we're 550. So either one will be
Either one would be
okay.
fine.
But we might want to choose a further one because of the spatial
Yes.
thing, just in case the motor comes too close to the
And also,
shaft.
when you have, the further away they are, if you're very, very close and you have a small pulley and a large pulley, you don't actually have that much engagement of the belt on one of the pulleys. As you essentially open the ankle of the belt. So the further away they are, they actually become
more
parallel, basically, the parts of the belt, so further away is
So
better,
the further the better.
I think.
Okay, so the centre.
I don't know why just a belt stretch and all those things, but we'll go with that. That seems a sensible selection.
Yeah, so the
So you need two
so our centre
pieces.
distance is 587.7 with this one, and the belt length is 1,600.
And we need to know the sprocket sizes, the pulley sizes.
Yeah, it's
so
0.24.
24, oh, you have that already, excuse me.
Yeah.
Right, the number of grooves.
Yes.
Yeah, so from the number of grooves we need to work out what the actual diameter is, and we have to have the diameter of the smaller pulley, the bigger than the motor.
Yes.
Or this one.
And how we
fit.
work that out is we need to first find out the pitch.
The pitch,
Yes.
is that given by this or not?
Okay, it's
Is that
the,
pitch or is
yeah,
that,
it's
is that the width?
the pitch. You're right.
Yes.
Okay, so somewhere there'll be
It
something.
says 8 times 1. 8
Oh,
times
that's
1.
Yeah.
Or is that referring to the space between teeth or is that referring to the width of the belt? I'm not sure.
I think,
Okay, if you find out, I note.
Okay. Here we have
Yeah,
it here. Okay.
yeah.
So what we have is reference dimensions. So the 8 MGT, the pitch, you're right, the pitch.
There's the pitch, yeah?
Pitch is 8.
Okay.
So the diameter,
it's
well, the
8.
circumference is 8 multiplied by 24.
Yeah. So,
Do we have the circumference?
Circumference is, it's
so
8 by 24, 8 by 25 is 200. Yeah. Yeah. Okay. So just have a calculator. Yeah, do you want to may as well pause safety tape. Is there a pause button on there?
stop.
Yeah, just press the record. Okay, so we're off again.
Yeah.
So we left it at, we have to,
So we have the pitch length just now,
yep,
and the number of grooves.
so the circumference is,
Yeah. So 24 grooves times the pitch length, which is 8 millimeter, times,
Sorry.
24 times 8, 192,
Yes.
and to get the diameter divide by pi,
Yeah.
and what does that give us?
the diameter of the
Yeah, oh sorry, what's the actual number?
one.
You have, what's the answer, mate, sorry?
It's 61. Point.
Well,
Yeah.
Okay, now going back, what was the size of our motor? Size of the motor
The shaft,
I
that
know.
was 42 mil,
yeah.
but that's the inner
Okay.
diameter.
Is there a particular,
Is there a constraint on that? Just saying what's the T? T is this. Do you know that speed? Because we have the outside.
okay, so
Yeah.
what we should be aware of is the actual pitch diameter is less than the outer diameter. So T is given as, we should perhaps rework this, where we work out the circumference. We have,
That was just the rough
yeah,
calculation. So let me put that more.
does it look like it will fit?
And then we have 61 on the outside, roughly.
That's not the outside, that's the pitch circle diameter. We have, they give you dimension T, which is essentially how the
How
diameter.
deep is the, yeah.
Yeah, so basically what we have is T of, is a
So minus
thickness of the
2T.
teeth, basically, the depth of the teeth. So we need to take away
Minus 2T, right?
2T, that's right, yes. Just essentially take away 7. So it's about 3.5. Sorry.
Is it 3 and, okay.
3. We're going for
So
8
we-
MGT, aren't we?
3.4.
So
Yes,
it's about
we're in
54. So, yeah,
54.
so we have 42.